Today we're going to talk about angles in triangles. So first, this should be nothing new, but we're giving it a name again. The triangle angle sum theorem says that all three angles in a triangle sum to 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. The exterior angle theorem is something that follows from the triangle angle sum theorem, and that says an exterior angle that is formed by extending any side of the triangle is equal to the sum of the two non-adjacent interior angles. Now this makes sense because if we called this angle 4, right, angle 4 and angle 1 form a linear pair, so the measure of angle 4, if we do 180 minus the measure of angle 4, that should equal angle 1, but that should also equal angle 2 plus angle 3. So the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. Okay, so remember those are the non-adjacent interior angles. To find a missing angle, we are just going to add the angles that we have and subtract 180, or do 180 minus the sum. So the measure of angle 1 here, I know that this angle is 37, this angle is 24, so the missing angle should be, right, this is 24 plus 37, which is 61. So the measure of angle 1 should be 180 minus 61, which is 119 degrees. Here I have an exterior angle, angle 1. I could sum these angles, subtract that from 180, and then fill this angle in and find the linear pair, or I can use the exterior angle theorem to find that measure of angle 1 should just equal 76 plus 52, which happens to be 128. So the measure of angle 1 is 128. For 3, I'm going to have to do a little bit more work. I have the measure of an exterior angle and one of the interior angles. I have the measure here, so I'm finding the second interior angle, so I'm going to set up an equation. It's going to be the measure of angle 1 plus 79 equals 104. So then I'll subtract 79, and I get the measure of angle 1 is 25 degrees. Okay, for number 4, I have multiple angles now. So I'll start with angle 1 because I have the two missing angles in this triangle. So 66 plus 84 is going to be 150. So then I know the measure of angle 1 needs to be 30 degrees. I'm going to jump down to angle 3. I know either I can do 180 minus 84 because this is a linear pair, or now that I know angle 1, I can just add angle 1 plus 66, and we know angle 1 is 30. So 30 plus 66 is 96, and that will be the measure of angle 3. And so I'm going to go ahead and label the picture with the angles that I just found. Okay, and then to find 2, I'll just add 96 plus 43, and I'll get 139. So I know that 2 needs to be 180 minus 139, which is 41 degrees. So it might help to start wherever you can, wherever you have at least 2 angles of one triangle, to find the third angle within that triangle, and then use the triangle exterior or the exterior angle theorem to find the missing angles in the second triangle, and then you can use the triangle angle sum theorem to find the remaining angles. So at this point, pause the video, try 5 and 6, and then resume the video to check your answers. Okay, so hopefully neither one of those was too difficult. 5 was very similar to 4. The only difference is we do have a right angle here, so that should have been your second angle within this triangle. 6, you would have used the fact that 2 and 61 are vertical angles. Then you have 2 angles within this triangle, and you have the 2 angles that you started within that first triangle. All right, 7 is a little bit different. Now we have a statement up here: BC bisects angle ACD. So I'm going to find angle ACD, which is this right angle here, and it's marked. So this segment BC bisects, so that means that 2 is congruent to 3. If we know the whole angle is 90, then we know that 2 is 45 degrees and 3 is also 45 degrees, because that is what bisect means. So here are 2 angles to start with without doing any work. So now within each triangle, I have 2 angles, so I can easily find the third. So for the measure of angle 1, I'm going to do 48 plus 45, which is 93, and then subtract 180 minus 93. So I find that the measure of angle 1 is 87 degrees. And then for the measure of angle 4, I'm going to add 45 plus 83, which is 128. And then I will do 180 minus 128. And I find that measure of angle 4 is 52 degrees. Okay, so we're going to flip over to the back and go ahead and try 8 and 10, and we'll check the video, or we'll check those answers once you resume the video. Okay, so take a second to look over your answers and make sure you got those. 8 was pretty straightforward. 10, you might have had to do a little bit of extra thinking, but we were using a lot of, we used a linear pair, we used the fact that angles were complementary, and then we can apply the triangle sum theorem. Okay, look at number 9. 9 is a little bit different. 9, here we have 2 parallel lines. So we know L is parallel to M, so I'm going to go ahead and mark that on my diagram so that I remember. So we're probably going to need to use some alternate interior angles in here to fill in some of the missing angles, and then we can use the exterior angle theorem and the triangle sum theorem to fill in the rest. So right away I notice that 49 degrees is an opposite interior angle with angle 4. So angle 4 should be 49 degrees also. Okay, and I like to go ahead and fill in the angles because I'm a visual learner, so that helps me keep everything straight and it shows me what I still need to find. So then I can use 49 plus 73 would be 122, and then 180 minus 122 for angle 2 would be 58 degrees. I'm going to go ahead and fill that in. Okay, I know that angle 5 should be a linear pair with 49, or I can use the exterior angle theorem and just add these 2 angles, the opposite or the non-adjacent interior angles, to get the measure of angle 5. And if I do that, I get 131 degrees. And I can do the same thing for angle 3. So this is an exterior angle, so 58 plus 49 should equal angle 3. I could also just do 180 minus 73 because they do make a linear pair. So the measure of angle 3, if I add 58 plus 49, I am going to get 107 degrees. And then finally, angle 1, I know either needs to be, because it's a consecutive interior angle, it needs to sum with angle 3 to 180. So I'll go ahead and write that in. That is probably going to be the easiest way to find angle 1. I could also add 49 plus 58 and then subtract from 180 because all three of these are supplementary. But I'm going to go ahead and just use the consecutive interior angles. So I'm going to subtract 107 from 180 degrees, and I will find that the measure of angle 1 is 73. And now I've found all of my missing angles. Okay, so number 11, I want you to try when the video is over, and we will check that one in class. So that one's a little bit more complicated and involved, but my biggest advice to you would be to label angles as you find them so that you can kind of keep everything straight. You will need to use the fact that this line and this line are parallel. You might be able to fill in using things like opposite interior angles. All right, so if we look down at the bottom, we're going to be using both of those theorems to solve for x. So let me see if I can get a little bit closer. This is kind of hard to see. Okay, so to solve for x, I'm going to need to set up an equation. So in number 12, I notice that I don't have any angle measures. They're all expressions involving x. So I can sum all of those together, and I know each of them added together should equal 180 degrees. 9x plus 3 plus 5x minus 2 plus 11x minus 21 equals 180. Okay, so now I'm going to combine my like terms. So I'm going to have 14x plus 11x will be 25x. 3 minus 2 is 1. 1 minus 21 is minus 20 equals 180. So 25x. If I add 20, I'm going to get 200. So x should equal 8. 200 divided by 25 will be 8. Okay, now I'm going to use that value of x and plug it into each of the expressions to find the measure of each angle. So the measure of angle D is 5x minus 2. 5 times 8 is 40, and 40 minus 2 is 38 degrees. The measure of angle E is 9x plus 3, so 9 times 8 is 72, plus 3 is 75 degrees. And the measure of angle F is 11x minus 21, so if I plug 8 in for x, then that's going to be 88 minus 21, which is 67 degrees. Okay, to double check myself, I can add 38 plus 75 plus 67, and I do see that that will equal 180 degrees. All right, so you are going to try 13. We'll check that one in class next time. And then we'll do number 14 together. And then you'll do 15 to check in class next time as well. So 14 now, I have an exterior angle. And I remember using the exterior angle theorem that the sum of these two non-adjacent interior angles should equal my exterior angle. So I'm going to set my equation up a little bit differently than the first one. Now I'm going to have 13x minus 11 plus 4x plus 1 equals 180 degrees, or not 180, equals 18x minus 15, because these two angles should sum to make the exterior angle. I will combine some like terms, so 13x plus 4x is 17x, negative 11 plus 1 is minus 10, equals 18x minus 15. I'm going to subtract 17x from both sides so that my x stays positive. You could subtract 18x from both sides. That would also work. You would just need to divide by -1 at the end. And then I'm going to add 15, so x equals 5. All right, so now measure of angle CAB is 13x minus 11. So when I plug 5 in for x there, I'm going to get 54. 13 times 5 is 65. 65 minus 11 gives me 54. The measure of angle ABC is 4x plus 1. So 4 times 5 is 20, plus 1 is 21. Now, the measure of angle ACB, I don't have an expression for that, but I do know these two angles. So if I add those up, I'm going to get 75. And then 180 minus 75, because this is the third angle in the triangle, will give me 105 degrees. Okay, and I will go ahead and add in my degree symbols. And then angle DCB is 18x minus 15, and when I plug 5 in for x there, I get 75, not 78. 75 degrees. Okay, so go ahead and try 13 and 15, and like I said, we will go over those ones next class.